remember that particular discussion which we had. Okay, but I would like to start with something which is shown on the first at the top, and then I wanted to come on this. Anyway, now that you have asked, so if you all can see, just wait. Everything else is there. So audible, screen visible, right?
Yes.
Yes, sir.
Yes, sir.
Yeah. Okay. So this is something on which Sejal asked in an individual chat, and I asked her to remind me actually in today's class, and I remember it. So I just wanted to write it here. So this is under this cross. I mean, not the top one, but the bottom one from earlier class on normal subgroups. I said that there was one definition of normal subgroup, one which was left coset is equal to right coset. And then we had a discussion on the classes, which were nothing but saying that a group contains all elements of the kind both H and X inverse HX. And we did this problem of equilateral triangle where we made three classes. So we found that the classes are such that the elements of the classes are conjugate to each other, and it's not possible that if R is conjugate to R square here, then R is also conjugate to L1 L or L2 or L3. So L1, L2, L3 were conjugate to each other. E, which is an identity element, is a class of its own. And then I said that the normal subgroup, if we have to form normal subgroup, that will contain complete classes. They cannot contain classes which are in between. So if I can think about making subgroups from here, so E element of course has to go. So I can think about making this guy and this guy. So let's say 1 and 2. One is surely going to form subgroup, which is nothing but saying that all the properties of the subgroup will be obeyed here. 2, on the other hand, I mean, you can think about making it like this, but you will find that this is not going to obey the properties of the subgroup. E, L1, L2, L3, they are not going to obey all the properties. So there were 4 properties: closure, identity, inverse, associativity. You'll find from the Cayley's multiplication table itself that this guy is not going to form subgroup. What I tried to say that if normal subgroup is formed, then it has to have complete classes. But it does not mean that every time you just add the classes, it is going to make you a subgroup. So first one is a subgroup and it is surely going to be a normal subgroup. Second one is not even a subgroup. Now, then there is a possibility, for example, EL1. You will find out that this is going to form a subgroup. But then since L1 is not forming complete class in itself, this guy cannot be a normal subgroup. It may be a regular subgroup. So figuring out the normal subgroup is that it can only be formed from the complete classes, and of course it will have to satisfy all the properties of the subgroup. It cannot be that it should not just have the properties of the group. Group properties have to hold true. But if it is from the complete classes and if it holds the properties of the subgroup, then it is a normal subgroup. On the other hand, there exist subgroups like EL1 kind of one, where it is not going to be formed out of the complete classes, and hence this is going to be a regular subgroup and not a normal subgroup. So questions on this, Sejal, or otherwise?
Sir,
No,
so
sir, I
L1,
got it.
Yeah, please go ahead, ask.
sir, जो L1, L2, L3 वाली class है, that will form a normal subgroup, will it?
That is no. If at all normal subgroup could be formed, then that would have to be a form of this, है ना? E L1, L2, L3. क्योंकि complete classes होनी जरूरी है normal subgroup में, right?
Yeah, sir.
But the problem in this one, E L1, L2, L3, ये complete classes तो hold कर रहा है, पर ये अपने आप में subgroup नहीं है कोई, यानी कि ये group की properties hold नहीं कर रहा. Remember, I told you classes themselves do not form subgroups. तो अगर possibility exist करती होती normal subgroup की, तो वो इस तरीके से होता. So what I wanted to say was ऐसा नहीं है कि आप हमेशा कंप्लीट क्लासेस को ऐड कर दो तो आपको एक सब ग्रुप मिल जाएगा जैसे नॉर्मल सब ग्रुप है. You will have to of course check the properties of the subgroup. So ERR square, just check the multiplication table whether it is closure etc or not there or not. And the same thing you will have to do it for this one, and you will find that it is not actually meeting the properties of the subgroup. So if at all you had to make normal subgroup, then it would have had this. But it does not mean that automatically every time you add classes, it is going to form a normal subgroup. So this is what a point which I wanted to actually emphasize. I hope अभी थोड़ा सा clear हुआ.
Yeah, sir, got it. Thank you.
Yeah. Okay, one question which I had from the previous class. I have a group. This is now coming on the top side. Consider a group G. So this kind of a group where I have elements like this. What kind of group I call this? G square, G
Cyclic.
cube. Right. And
Cyclic.
where G is the generator of this group, right? अच्छा, अगर मैं इसमें दो एलिमेंट लेता हूं G square and G cube, what is the composition of that? G square dot G3. What will it give? So that's the
G5.
question. So this will give you G5. Is it member of the group?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. It is member of the group. So it is fine. Now, what about a composition G4 dot G5? What will be the result of this guy?
G raised to power 9.
G ने raised to power 9. अब ये composition है क्या इसमें?
No, sir.
तो फिर ऐसा
G.
कैसे?
So we can write it as G की power 6 into G3.
Right. So you can write it something like G raised to power 6 times G raised to power 3, where G raised to power 6 is what?
E.
Identity,
E.
which is equal to
J cube.
Power.
is G cube there?
3.
Yes, sir.
Yes. So
Yes, sir.
please see that when we are saying that the multiplication table is such that the closure property is met, compositions may you will have to figure out at times that even though G raised to power 9 may not be explicitly here in this cyclic group, but it is there in some form in terms of a distinct element G cube. What about G raised to power 12?
E.
G6 into
Right.
G6.
So G6 dot G6 equal to E. Is that there in this group?
Yes, sir.
Yes, that is there. So
Yes.
please see that the cyclic group property is such that you can just take composition of anything. In fact, you can go beyond that. You can now think about going to G12 times G5, so G17, so on and so forth. Everything will map back to this group, which is the group I have given you. So that's something which I just wanted to explain. Questions on this? No, that is pretty much clear. Okay, good. Okay.